Hey there guys, Professor Romani again for your corporate finance class, and today we'll be focusing on retirement, primarily of money problems. Okay, so retirement problems. Okay, so whenever it comes to retirement problems, the basic idea is um, you have some sort of like money needed. Okay, this is the time of retirement, and you live post-retirement, and you estimate, I don't know, some time of death. Okay, to simplify that idea is like at time of death, you either give $0, you have no money remaining, or you might decide to give some sort of income. And whatever leftover money is there is the inheritance. And this is now. This now can be 20 years for most of you. This now could be 25 years. This now could be, you could be 35 years old. You know? Or you could be 40 years old with nothing saved towards. So, okay. And so if you want to try and figure out how much money you need for retirement, is one part of the puzzle, and how much money do you need to save for retirement, as if you need like R retirement amount of dollars, R dollars, how much do you need to save in terms of C every year or every month or every week, every 2 weeks, whatever it is. That's how these problems in some sense work. So first step to try and figure out how much money you need, because these R dollars, is to try and figure out how much will you spend per year or per month post retirement till you reach till you die. And once you have those S amount of dollars, all these S can be used to figure out R dollars. Using these R dollars, you could what your C will be. And some important pieces of puzzle are what will be the rate of return, or the discount rate, however you name it, rate of return, discount rate, inflation, some sort of R, some interest rate, which is used to calculate your um, MLF money, and how much will be your rate of return or discount rate, R, in this time period. Okay? So this could be like an R1, this could be an R2, which is like two different kinds of interest rates. To simplify it, or you could have a same interest rate if you want to simplify it even further. You could make an assumption same throughout this time, or like a period of 50. So you could start getting more complicated, less complicated. Now let's try and actually look at an example problem from your textbook or from the handout exercise. So this is, I'm going to focus on problem number 10. So problem number 10. So if you save $10,000 every year and the savings interest rate is 7% a year for 20 years, 5% for 10 years, 4% for another 10 years, how much money will you save for retirement? So here you have 40 years till retirement. Most rate. So 40 years until retirement. This is now time period years. Okay, so but this 40 years is split into three different parts. So this is a very typical example of how you invest in a very aggressive portfolio. For the first 20 years, you have interest rate is 7% rate of return. For the next 10 years, you have rate of return of 5%. As you get closer towards retirement, start investing in more conservative portfolios, which do not give you much return, but is money is a lot safer, presumably. So this is now. So for the first 10 years, let's say you're investing $10,000 every year. Okay, for 20 years, and every year you're investing $10,000. That's all you're doing. Every time period, all the way, you're investing $10,000, and you have 40 time periods before you go to retirement. Okay, so now we could try and break this up into. Let's make an assumption that the first payment is made at the end of each time. This is one, two, so and so, till 40. Okay, so the last payment is made at the end of just as you retire. That's our assumption, and we're doing this. So your first step is to try and figure out how much money will you have at the end of 20 years, end of 30 years, and then finally at the end of. So for the first 20 years, this is an annuity of $10,000. Oh, I realized I didn't go. This is again, I'm just writing the same problem. 20 years, 30 years, and 40 years. So for the first 20 years, this is an annuity problem, and the present value of the annuity is going to be C by R. There's no growth rate in this equation. You're investing a constant $10,000 every time period. 1 minus 1 by R whole power 20 years. Okay, and the future, you want to know how much money you'll be having at the end of 20 years. So the future value of this problem is going to be the present value of the annuity. This multiplied 1 plus whole power 20. Okay, so the future of the annuity times 20. This is just going to be C by R. C is $10,000. 10,000 divided by R. Your R rate of interest for the first time period is 7%. Here, 0.07 to 1 minus 1 by 1.07. Multiply that by 1 plus R whole power 20. R over here is 7%, 7 whole power 20. Okay, so this is how much money you will have at the end of 20 time periods. So I'm going to try and quickly calculate that using the financial calculator. So present value, right now you have no savings. I'm entering that as 0. We're assuming that every payment is made at the end of each time period, which is end mode. Payment is going to be negative $10,000, losing $10,000 every year. So you're making a deposit. Blank. You want to find out the future value, you leave that blank. Annual rate is 7%. Done annually because number of time periods, 20 time periods. Okay, once you have that, that's how much money you will have. 409,954. Okay, so this is how much money you have at the end of 20. That is 7%. So now, at the end of 30 years, it's going to be something very similar. Now it's going to be the future value. It's going to be present value of the annuity. Okay, so present value of the annuity, and think about this. Present value of the annuity payments from 20 to 30 years. Okay, so this is going to be C by R, the same formula over here. 1 by, but we want to know the future value. Okay, so the future value of the is going to be the present value of the annuity payments for years 20 to 30. Make sure you write out the subscript so that you don't confuse. Oh, multiplied by 1 plus r power t is 10 here. So this is going to be $10,000 r point, but now the interest rate has changed for 20 to 30, that's 5%. Okay, in this scenario, the interest rate 0.05 by 5 whole power 20. No, it's not 20 because years 20 to 30 comprises of only 10 years. Okay, so this, again, once you have this, you can compute that financial calculator. The only thing, two things which change is interest rate becomes 5%, and time period becomes 10. Assume you have, if you're willing to do it in 2 steps, you leave present value as 0, and remember you're trying to compute the value. I don't know how it's working. So the present value is 0. Here, error. Start this calculator. Present value is 0. Payments is $10,000 per year. Which value is what you need to find out. Annual rate is 5%. Number of time periods is 10. And it's annual. Compute the future value. This is 125 cents and 8.9. So this 125 cents on 8.93 is the present value as the future value of all the payments which you made between years 20 and 30. So 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Those 10 payments of $10,000 in each time period, compounded at 5%, would have resulted in an annual amount of this. But you also know that this value will also carry over to the future. Okay, so you could do that later or together. The calculator, when you're calculating this financial calculator, one way to try and think about that is to make sure you enter 409,954.92. That's the present value. But when you're entering, it has to be negative. It's because these two are your save for retirement. And then if you try and compute future value this way, your total value this is going to be 793,552.3. Okay, so that's going to be a total value which will be available in your bank account at time 30 years from now. And now you need to find out the same as total value at t is equal to 40. So now the last part, which is all the payments between years 30 and 40, starting in year 31. Now the rate of interest is 4% in this. Last payment being the year. Right. And so the future value of this annuity, present value of that multiplied by 1 plus r whole power t is 10 and 4. This is going to be C by R, $1,000. 0.04, 1 minus 1 by 1 plus R, whole power. Present value, the future value of this annuity would be 120,000, 061.7, and the total value is equal to 40. It's going to be in your calculator, if you enter the previous total value, 793,552, 9, compute future value. That's how much money you will have at retirement. Okay, so this is the total amount of money you have at retirement, and that's the answer value for 10. Okay, so now here, another way to try and think about this is if you try and do the individual cash flows. First 20 years, you had around $409,000, 409,954. I'm just going to round it up to 955. And here you have another $125,000, 179. And here you have 121. Okay, so now this 10 years time frame, 10 years in this first 20 years. So this kind of reduces to a much smaller problem, where if you need to take this up there, take 125.79 into the interest rate is 4% in this time period, 1.04 the whole power 10. I'll give you a value. This value, this 20 years of time period, this could be thought of as the future value is two present values. Here you could think about future value is going to the present value, present value 1 or into present, but not really. Explaining. So the future value, this 409,955, the typical relationship with present future value is just the present value 1 plus r whole power t. But this t has 20 years, but since the r differs in two different times, this could be thought of as the present value 1 plus r1 the whole power t into 1 plus r2 the whole power t. Okay, so this you could split up the future value of 20 time periods as present value to 1.05 whole power 10 and 1.04 the whole power. That's going to be 409.5 to 1.05 10 to 1.04, and that'll give you a value. And then you add this value and this value and this value. That should be the same as 1294712. Okay, so this is your final value. You should be getting the same no matter how you do. Okay, so another kind of retirement problem. So this did not take into account the spending after you retire. Okay, so now let's try and figure out another kind of similar problem. I'm going to try and use the same weights. Okay, so this is now. Okay, I'm going to simplify in some other sense. Whatever you save till retirement is going to be 6% on average. It's going to be your return on investment. And let's say you will be living 20 years after retirement is your average, or 25 years after retirement is when your debt and any money, like you will have $0 left at 90 years old, like that. So retirement's at 65, about 25 now. You have 40 years to plan for your retirement. And If you're planning your retirement this way, let's assume in today's terms, and let's say this all these returns are all real returns, and in today's terms, you will want to spend $30,000 a year. Okay, so every year, $30,000 is what you plan to spend. So let's say you think you would have paid off all your mortgage by then, and these $30,000 a year is all you require in terms of actual spending money, a little bit of trips, eat out. That's your total expense. So $30,000 a year is your expense. How much money do you need to save each year in order to afford a lifestyle? Spending $30,000 every year, retirement. Let's assume that the rate of return after retirement be 3%, 20 years. So once you have this sort of assumption, this is where you start at the end. If you have to spend $30,000 in your retirement, so your spending or payment, and this is constant every year, so it's going to be an annuity problem again. Present value of that annuity would give you how much money you need to retire. You're spending $30,000 a year, and the average return you will receive in this time period will be 3%. It will be 1 minus 1 by 1.03 the whole power, and for 25 years. So this is how much money you would need to at retirement. So let's try and take all these. So your payments, you will be spending $30,000 a year. Present value is what you need to find out. Future value is how much money you plan to leave for inheritance, which in the scenario is zero or after your death. Rate of return is going to be 3%, 25 years, everything's compounded annually. Compute the present value. So in order to afford a lifestyle of $30,000 a year spending for 25 years after retirement, you would need to have 522,394.4. You need to have this much money in your bank account, just the money needed for. Okay, so that is how much money you need to have at retirement. But how much money do you need to put away each year in order to reach that amount? So now this is going to be the future value. Future value of annuity would be the present value of annuity multiplied by 1 plus r the whole power t. Okay, so this time frame is where t is 40 years. R in this time period is 6%. So this is going to be, you will be finding out C by R is 6%. 1 minus 1 by 1 plus R, 1.06. Whole power 40. That's the present value of the annuity. And multiplying this by 1 plus R, 1.040. This whole value is going to be 520,394. Okay, and from this equation, solve C. And that is how much money you need to put away each year in order to reach this 520 target. Okay, so, and this you could solve again in your calculator. Future values now, value on that comes your future value. And the payments is what you need to find out per year. Present value, you have $0 and say annual return is 6 years. You're going to be saving for 40 years. So when you do that, oh, it's giving me a wrong value. Let's read out the calculator. Present value 0. Payments is what you need to find out. Future value is 522,394.3. Annual rate of return of 6%. You'll be saving for 40 years and compounded. Once you do this, payment is 3375.4. Okay, so if you try and think about this problem which we had here, that's how much you need to save here in order to be able to offer. It's not that much. If you try and think about it, if you in order to get assuming you get 6% return and you get 3% real returns post, right? Even if you reduce this, if you're less optimistic, you could reduce this rate to 4. Reduce this to 1% or 1.5%. You might have to save a little bit more each year. This might jump up to 5,000. But it shows you in order to save for retirement, that's how much you need to save each year. So in order to be able to live comfortably post. And these are two examples of retirement problems, and I would suggest you could work out a couple more from the end of your textbooks, the intermediate and the challenge sections, in order to practice this. Okay? And try, instead of a year, try solving in terms of monthly. That could be a different try, and once you get comfortable with that, that should help you with this chapter. That's it for this chapter. I'll see you all next week. Bye.